There are a lot of videos on these subjects, but I thought I'd show you how I did it in case anybody has run into similar issues. And I'll show you one trick that I had not seen mentioned elsewhere. My terminal has 8 platform tracks, 2 coach tracks, and a small freight yard. I built the throat trackage during the COVID lockdown and probably made it more complicated than necessary. There are many ordinary number 7 switches and crossovers, several curved switches and crossovers, and 3 three-way switches. There's also a scissors crossover on a curve with movable points in the middle because the angle of the crossover was too obtuse and I was getting derailments. I have not ballasted this track work yet, for fear I would get every moving part glued solid. Yes, it was definitely more complex than necessary, but it was fun and I enjoyed the challenge. Here's the spaghetti farm underneath. I'm not an engineer and it could have been neater, but you can see the close spacing of the various devices needed to throw all those switches created issues. Note especially the orange boxes. The one on the left is under the movable points in the middle of the scissors crossover. So the question was how to throw all those turnouts. I like tortoises, they work well, and they have extra contacts to feed the frogs, and they're relatively easy to mount. I used them whenever space allowed, but their footprint was much too big for some of those closely spaced switches and crossovers. I just couldn't fit them all in without complicated linkage. Should I use the MP1? Well, it's much more compact than the tortoise. It's apparently been on the market since about 2015, but I'm not sure they were available in the US back then when I built this terminal module. Unlike tortoises, I don't think you can drive 2 of them simultaneously from a single output on a Digitrax DS64, so a crossover might present issues we used with the DS64 if you want both switches to throw simultaneously. But the MP1s do shut off after moving, so they draw no current when they are at rest. They seem to cost about the same as a tortoise. If I had to do it over again, I would probably use them instead of servos and work around the DS64 issues. So in the end, I used about 20 of these very inexpensive servos wherever tortoises would not fit. There are several commercially available types of servo mounts. In some mounting configurations, such as the one shown here, the servo horn rotates in a vertical arc relative to the track. This causes the actuating wire to uselessly move vertically while doing its actual work of moving from side to side. Even when properly adjusted, abnormal servo activity can pull the actuating wire down and disengage it from the throw rod. Then you have to remove and remount the servo. Many servo drivers allow fine adjustment of the servo throw and endpoints to keep it within a narrow range and avoid having the actuating wire go up or down too much. But there's a better way. Mount the servo so the horn swings horizontally. Several such mounts are available commercially, but I made my own, which you can see here. I cut a piece of a 1/2-inch aluminum channel about 2 inches long. Drill 3 holes, as in the picture on the right, 1 for the pivot, which is approximately 1.2 to 1.5 millimeters, and 2 for mounting screws. Make the mounting holes large enough to adjust the channel fore, aft, left, or right relative to your hole in the baseboard. I attached a .030 piano wire to the horn as you see in the pictures, bending the short end over the wire firmly in the horn. You don't want the wire to be able to swivel in its hole in the horn as the horn swings. Use one of the outer holes in the horn. This allows the servo to use a wider arc of travel, which I think makes its work easier. Run the actuating wire up through the small hole in the channel and then attach the horn to the servo spindle with that minute screw that came with the servo. Make sure the servo is at mid-travel by turning the spindle gently using the horn so it can rotate equally to either side. Squeeze the channel with pliers to make it a bit tight. Then insert the servo into the channel so that at mid-travel the wire passes through the small hole in the channel, straight and not on an angle. A few drops of ACC glue down each side of the servo will hold it in the channel firmly. Now in this configuration, the actuating wire swings back and forth enough to throw the throw bar, but with very little vertical travel. Another advantage of this method is that the servo is mounted under the baseboard in line with the switch it is actuating, so that it requires barely more lateral space than the track above. This allows servos to operate switches on adjacent tracks without physically getting in each other's way. Now from this point, I'm going to just call tortoises and servos switch machines because everything applies equally. This section would also apply to the MP1 and its brethren. I have had to spend many hours on the floor trying to blindly fish the actuating wire up from below, through the 1/4-inch hole in the baseboard, and then through that tiny hole in the throw bar, and get the switch machine properly located so the actuating wire would move the throw bar freely and properly. I figured out a little trick. Don't use a short actuating wire like the one that comes with the tortoise. Start with one that's 2 or 3 feet long with a hook on the end. Thread the end without the hook down through the throw bar from above. The hook is to keep it from falling straight through to the floor. At this point, make sure the actuating wire and throw bar have room to move fully from side to side without fouling the sides of the hole in the baseboard. Then go sit under the layout and find that long actuating wire dangling from above. Make the appropriate bends in the lower end of that long wire and attach it to the switch machine. The MP1 does not need any bends in the wire. Then lift your switch machine up to the hole in the baseboard, letting that long wire guide the location of the switch machine back towards its proper mounting place. Use double stick tape to temporarily attach the switch machine to the underside of the baseboard in what you hope is the right position, while you crawl out from underneath and check that switch machine will move the throw rod freely and fully. Go back underneath and make any corrections before affixing the switch machine permanently with screws. Note that the MP1 includes some mounting slots to adjust it fore and aft relative to the hole in the baseboard. Once that's all adjusted, cut the actuating wire about a 1/4 inch above the throw bar. Make sure at this point that if the actuating wire does rise or fall, it will still stay engaged with the throw bar at all times. Finally, grind the stub of the actuating wire off just barely above the throw bar. Now, if worst comes to worst and the actuating wire does rise and fall noticeably, you can allow it, when at rest, to protrude above the throw bar, but not above rail height where it will inevitably foul a train. Save the remaining long wire for the next one. And that's it. I hope this was helpful, and thanks for watching, and subscribe to my channel.